All right, once again, first step, I'm just going to write this out. So cotangent theta over cosecant plus 1, and on the right, it's cosecant minus 1 over cotangent theta. This is a real typical setup for a conjugate trick. Now, I can tell it's a conjugate trick because on a diagonal, I got a cosecant plus 1 and a cosecant minus 1. So it could be the other way around, cosecant minus 1 in the denominator and cosecant plus 1 on the other side in the numerator. But this is what a conjugate trick always looks like. And what I'm going to show you is just what the typical way is to deal with this. So what we usually do is pick one side, and you're just going to work on one of the two sides, and you're actually going to get everything done just on that one side to equal the other side. And how you do it is you multiply whichever side you pick, you're going to multiply by the conjugate from that side. So because I'm going to work on the left, I'm going to multiply top and bottom by the conjugate of cosecant theta plus 1, which is cosecant theta minus 1 over cosecant theta minus 1. If you wanted, you could not work on the left, you could work on the right, but you would multiply top and bottom by cosecant theta plus 1. Okay? So it's your choice. It doesn't matter which side, but you only work on one of the two sides. So now when I expand this, this is cotangent theta times cosecant minus 1. Because they're not conjugates, I'm not going to multiply those out. I'm just going to leave it in brackets. But in the denominator, when you multiply conjugates, I'm going to actually FOIL this thing out. I didn't in the other question when multiplied conjugates. But just to show you that when you FOIL this, so multiplying the first, cosecant times cosecant is cosecant squared. Cosecant times negative 1 is negative cosecant. 1 times cosecant is plus cosecant. 1 times negative 1 is minus 1. That negative cosecant theta plus cosecant theta cancel out, so all you're left with in the denominator is cosecant squared minus 1. What's important is that you really don't, everything I highlighted in yellow in that second step, you don't need that step at all. Typically, I just full it. So it's just skip the outside and the inside, just multiply the firsts together and the lasts together. Okay, you might be wondering, why wouldn't I expand the numerator? And it's because nothing good comes out of multiplying cotangent theta by cosecant theta minus 1. And I know that. It's actually better in its factored form. So that's something you also have to look for sometimes, is whether expanding does anything for you. If it doesn't do anything for you, don't expand it. Just leave it factored. So the numerator gets left alone, but what always happens with a conjugate trick is that usually when you multiply two conjugates together, you get a Pythagorean identity. So cosecant squared minus 1 is the Pythagorean identity here, and I know that equals cotangent squared. Then that cotangent, because I didn't multiply it through, it's easy to see that it's going to cancel. So I can cancel the cotangent with the squared. So this is just going to be cosecant minus 1 over cotangent. Left side equals right side, and we're done. Make sure, if you'd expanded this, always factor that cotangent out before canceling it out. You don't want to make that mistake, because what happens is a lot of times you'll just cancel one of the cotangents out with the denominator, and that's not right. It always needs to be factored out as a GCF and then cancel it out.